derive the solution of the following ordinary differential equation by the variation of parameters. Okay, so we have a non-homogeneous second order constant coefficient linear ODE. To solve this, we first consider the corresponding homogeneous. So consider y double prime minus 5y prime plus 6y equals 0, and we know how to solve this. To solve this, we find the characteristic equation, and the characteristic equation is r squared minus 5r plus 6 equals 0. Now we solve this quadratic equation for r. So factor this, r minus 2, r minus 3 equals 0. That implies r equals 2 and 3. So based on these two real and distinct roots, we have two solutions, e raised to 2t, let's say y1, and y2 e raised to 3t. Okay, there are two solutions, and the general solution of this homogeneous part, or which is same as the complementary solution for this. So y complementary for the original equation is now C1 first solution plus C2 second solution. Okay, now based on this complementary solution, we find a particular solution, and the sum of this complementary and particular will be the solution of the original ODE. Now we let y as a particular solution. We just vary these coefficients by these parameters or coefficients by functions of t. So we write, let's say, u and u1 and u2. So u1 as a function of t, e2t, plus u2 as a function of t, e3t. Let this be a solution, okay, of the given, the original ODE. Now we need to determine u1 and u2. As soon as we find u1 and u2, then yc plus yp will be the solution of the original. Now to determine u1 and u2, we plug this y into the original ODE. Here we go, original, where we have y, y prime, y double prime. So we need to find y prime and y double prime. So let's go for that. Let's find y prime derivative equals, so we have a product of two functions here plus u2 times e3t, another product. So let's use the product rule. So I'm going to drop this t. Using the product rule, derivative of first factor times second plus other way around, derivative of second times first. So this is 2e2t, so 2u1 e2t. Similarly for the second product, derivative of u2 times e3t plus derivative of this 3 u2 e3t. Okay, and we find second derivative, and then plug these y, y prime, y double prime into this original ODE. Okay, then we get a condition, we get a relationship between u1 and u2. So we are we get only one relation, but we are trying to find two values, u1 and u2. So if there are two unknowns, then we can have two equations. So now we're gonna put another condition now that makes our life easier. So what I'm gonna do here is, let's assume u1 prime e2t plus u2 prime e3t be 0. That's a condition on u1 and u2. Okay, so assume u1, okay, this is u1 prime e2t plus u2 prime e3t be 0. Okay, later we use this. Okay, then when we assume this, so y prime then becomes, this is gone, so 2u1 e2t plus 3u2 e raised to 3t. That's y prime. Now we find the second derivative. So we have to use product rules again in two terms. So derivative of 2u1 is just 2u1 prime e2t plus derivative of e raised to 2t, that's 4u1 e raised to 2t plus, now use another product rule here, derivative of 3u2 is 3u2 prime, leave e raised to 3t alone, plus take the derivative of e raised to 3t, which is 3 times itself, so 9 u2 e raised to 3t. Okay, and let's simplify this if we can. There are no like terms. Okay, now we plug y prime and y double prime into the original ODE. Substitute y prime and y double prime into the original ODE, okay, into which is y double prime minus 5y prime plus 6y equals, look at here, 2e raised to t, 2e raised to t we get. So y double prime is here, so this is y double prime minus 5y prime, so we multiply this by negative 5y prime plus 6y, and y is here, we multiply this by 6 and we add, that is equal to the right hand side. Okay, so y double prime is here, so let's write this 2u1 prime e raised to 2t plus 4u1 e raised to 2t plus 3u2 prime e raised to 3t, and the fourth term is 9u2 e raised to 3t. That's y double prime minus 5y prime. So let's multiply this by negative 5. So negative 5 times 2, 10u1 okay, e raised to 2t minus 5 times 3, negative 15 u2 e raised to 3t. That's negative 5y prime plus 6y plus 6 times y prime on the top, 6 times the original. So let me drop this t. So 6u1 e raised to 2t plus 6u2 e raised to 3t. 6u2 e raised to 3t is equal to, the right hand side is 2 e raised to t. Now in the left hand side there should be some cancellation. u1 e to the 2t, u1 e to the, here is u1 and here is 1. Okay, 4u1 e to the 2t, 6u1 e to the 2t minus 10. So 4 plus 6, 10, minus 10 cancel. So similarly we should have another cancellation. Let's see, negative 15u2, and we have here is 9u2 e3t, negative 15u2 e3t plus 6u2 e raised to 3t. 9 plus 6, 15 minus 15, they also cancel. Okay, then we have 2u1 prime e raised to 2t plus 3u2 prime e raised to 3t plus 3u2 prime e raised to 3t is equal to, right hand side is 2e raised to t. So this is another condition on u1 and u2. Let's say equation 2. Now we solve equation star and equation double star 1, 2 for u1 and u2. Okay, let me write star here so that it will be easier to compare. So we have u1 prime, I'm just writing star from the above, plus u2 prime e raised to 3t equals 0. That's what we assumed. That's star. Now we solve this system of linear equations for u1 prime, u2 prime. Once we have u1 prime, then we integrate to get u1. So let's try to cancel this second term. So we have 3u2 prime e3t, only u2 prime. So let's multiply equation this by -3. Okay, if we multiply by -3, then combined with 2, so what we are doing here is 2 plus -3 star. Okay, we multiplied the star equation star by -3 and add with first, then these two terms cancel, and this is -3 u1 prime. Okay, once we multiply by -3, so 2 u1 prime minus 3 u1 prime, that leaves -1 u1 prime e raised to 2t. This is gone, and -3 times 0 is just 0, equals 2 e raised to t. From this, let's find u1 prime. So divide by -e to the 2t. So u1 prime is 2 e raised to t already in the right hand side, divided by -e raised to 2t, a negative in the front, et, move this to the top, t minus 2t, -t. So this is -2 e raised to -t. That's u1 prime. Then we can integrate both sides with respect to t to get u1 as a function of t. If we integrate this, integration of e to the -t is itself divided by -1. Okay, itself divided by -1, that makes +2 e to the -t. That's u1. So from these two equations, we cancel the second terms, then we found u1. Now we do the same thing, same type of thing, and try to cancel first terms. Okay, so here is 2 u1 prime. We have u1 prime, so let's multiply star by -2 and combine. So basically we are doing now second equation, plus we multiply star by -2 and add. When we do this, okay, you don't have to write this, then we're gonna get first terms cancelled. So 3 u2 prime e to the 3t, this will be minus 2 u2 prime e to the 3t. So 3 minus 2 is just 1. So we get 1 u2 prime e raised to 3t equals 2et minus 0, just 2 e raised to t. So from here, let's divide by e to the 3t, you get u2 prime equals 2et divided by e to the 3t, which is 2t minus 3t is -2t. Now integrate both sides with respect to t. We get u2 as a function of t. So entire derivative is itself divided by -2. -2 and 2 just -1 e to the -2t, plus c is not needed. Okay, so we have now u1 and u2. Then a particular solution was, if we go up, our particular solution was here, yp. Okay, u1 e2t plus u2 e3t. So u1 we just found here, 2 e to the -t times e2t, plus u2 which we just found -e to the -2t times e3t. Okay, let's simplify. 2 et e2t, 2t minus t, just 1t, this minus here, e3t times e to the -2t, we combine the exponents, this is et. Oh, they are same. 2et minus 1 et, is just 180. So a particular solution is just e to the t. Then hence the general solution for the original, the given ODE is yct plus ypt, and yc was, if you go up you will see c1 e to the 2t plus c2 e to the 3t plus a particular solution is e to the t. These are all unlike terms, and that's the final answer.